Good morning, everyone. It's Mrs. Kardos. Welcome back to another lesson. And our topic today is constant of proportionality from a table. If you have your supplies or your notes from class, awesome. And if not, take a moment to pause the video, go grab them, or if you don't have any notes, just grab some paper and pencil. Our lesson target today is that students will be able to identify the constant of proportionality from a table and use it to compute missing information. And as always, we're going to demonstrate this by completing some practice problems. So when we're talking about proportional relationships, in order for a table to represent a proportional relationship, it must meet two criteria. The first is that it must represent a relationship that it is changing at a constant rate. So there's that word constant again. So constant of proportionality, constant rate. You can think of it like the same. Constant means something that's going to stay the same. If I say you're constantly talking in class, I mean you're doing it like all the time. That behavior doesn't change. So we're looking for a rate that does not change. It stays the same. If we were to graph it, it's going to mean that we get a line that's linear. Okay, so we're going to get a straight line. We're going to get a graph that would be linear. And the second criteria is that it has to represent a line that when we graph it is also going to pass through the origin. And remember, the origin would be our points 0, 0 on a 4-quadrant graph. So let's try a practice problem here. And remember, as we're doing this, you can always pause the video and try it for yourself and then come back to the video to see if you have it correct, or pause the video to take notes. So for this one, it says, determine if the following table represents a proportional relationship. Well, the first thing I'm going to look at is the origin piece. Does it go through the origin? And in this case, yes, it does. So that criteria is met. So now I have to test for the second criteria, which would be that it's changing at a constant rate. And in order to do that, I'm going to divide the y divided by the x. So when we're looking for our constant of proportionality, we're dividing the y divided by the x. And remember, the variables could change. We're really looking at the form because when you see these on tests or in other problems, sometimes they might not use a k, they might use an r. Or instead of using y and x, they might use an m and an h for miles and hours. So just keep that in mind as we go along. But in this problem, they tell me that the hours are the x and the miles are the y. So I'm going to take a minute and I'm going to test each one of these. So 50 divided by 5 is 10. 70 divided by 7 is 10. And 80 divided by 8 is 10. So this would be a proportional relationship because I meet both of the criteria. Okay? I have 0, 0, the origin, and I'm changing at that constant rate. So here's another one. Take a moment, pause the video, look at it, see if you can decide if it meets the two criteria, and then come back to the video. Okay, so the first thing I notice about this graph, because I always like to check the origin first because it'll save me some work with my calculator if I notice the origin first sometimes, is that this origin, does not go through the origin. It does not go through the origin. So when I graph it, okay, it's not going to start at the origin. It's going to start up here at 2. So this tells me that it is not a proportional relationship. So even though if I took the time and I divided each one of these, and I see that yes, when I divide the y by the x for the price in the pounds, that I get $2 per pound each time, okay, this is going to keep it from being proportional. So my answer for this one would be that it is not proportional. All right, let's check this one. It says determine if the following table represents a proportional relationship. Well, I can see that it goes through the origin. And if they did not show the origin, then I would have to figure out if it would go through the origin, either by graphing it or by maybe backwards mapping some numbers to find out, working backwards to find out if it would go through the origin. But in this case, we do see it meets that criteria. So now I need to check my k, my y divided by x for each one of the points that I'm given. So in this particular instance, 30 divided by 6 is 5. 60 divided by 12 is 5. It's looking pretty good. But if I do 808 divided by 18, I don't get 5, I get 6. So this one would actually be not proportional, because it meets the 0, 0, the origin, but it's not changing at a constant rate. So if I graph it, it's not going to be linear. All right, so remember, just to sum it up here a little bit, the constant of proportionality K is another word for the unit rate or the rate of change. And sometimes you may also hear it called slope in other problems. So constant of proportionality. So the table below represents a proportional relationship. Fill in the missing number. So I already know that this is a proportional relationship. So I know that if I graph it, it should make a straight line. So I can see that it goes through the origin. It's telling me that we've got some money earned for a certain number of hours worked. And so they gave me some information, and I have to fill in what's missing. So the first thing I'm going to do is find my constant of proportionality, and I'm going to do that by dividing the y divided by x. Now, I can't use 0, 0, because if I try to divide by 0 on my calculator, it's going to say I have an error, because you can't divide by 0. So I can't choose that one, but I can choose this point right here to find my constant of proportionality. So if I take my y, 75, and I divide it by my x, 10, I wind up with 7.5 on my calculator. Now, if I'm thinking about this in the context of my problem, we're talking about money, so it's actually going to be $7.50 per hour. So now that I know the constant of proportionality, the K, okay, or the rate of change, now I can figure out how much money I would earn if I worked 18 hours. And you can, if we rearrange those letters we had earlier, we can have a nice equation here, and I can fill in my K, my constant of proportionality is $7.50, and I want to know how much I would earn if I worked 18 hours. And if I use my calculator or not, my brain, the best calculator of all, I would figure out that the missing number is $135. Okay, so found the constant of proportionality, used the y, one of the y divided by x's that we were given, one of our coordinates, and then just put it into the equation that we've used before, y equals kx, and found out the missing information. Now we can see on this slide that yes, we did have the answer correct. So that's always good to know. All right, this is the same type of problem, except instead of having a missing blank box on my table, they ask it in the form of a question, but it's still the same type of problem. For this problem, it says that the table represents the price of apples per pound. So, and it asked me to identify the constant of proportionality K, and then to compute the cost of 13 pounds of apples. So I can see, obviously, if I don't buy any pounds, okay, it's not going to cost me any money, right? And if I buy 2 pounds of apples, it would cost me $2.62. And if I bought 5 pounds of apples, it would cost me $6.55. So I have to do step A first. I have to identify my constant of proportionality. So I need to do my y divided by x. It doesn't matter which y I choose, y and x I choose, okay? But they have to go together. They have to be a pair. So I could choose this pair or I could choose this pair. But remember, don't choose 0, 0. Pause the video, take a minute, see if you can work it out, and then come back. So if I did that on my calculator, I like to use the smaller numbers because sometimes I can even do those in my head. I wind up with, let me zoom in here a little bit, $1.35 per pound, okay? So that's my constant of proportionality, $1.35 per pound. And now I can do part B, which says compute the cost of 13 pounds. So I'm going to use my equation, y equals kx. I know the k is $1.35, and I want to know what 13 pounds would cost. So if I work that out on my calculator, sorry, I don't know why I put $1.35. It's $1.31. See, I need you guys to catch all my mistakes. So $1.31 times the 13 pounds, I would actually wind up with $17.03. So 13 pounds would cost $17.03. So let's check. Yes, caught my mistake just in time. So yes, so $1.31 per pound, $17.03. Okay, so here's another problem. It's very similar to that one. Pause the video, see if you can work it out, and then come back and we'll work it out together. So hopefully you did that. This table below represents the relationship between the number of miles traveled and the time in hours. And again, they're asking me to identify the constant of proportionality k and then to compute the number of miles traveled in 7 hours. So again, I'm going to use my smaller numbers. I'm going to choose this coordinate or ordered pair. The x is my hours, the y is my miles. So 204 miles divided by 3 hours, it works out to 68 miles per hour. So this is their constant rate that they're traveling at. And if I went ahead and divided 408 divided by 6, I would see that it also comes out to 68. So it is definitely a constant rate. And now I'm going to use my equation, y equals kx. So the k is 68. And we want to know 7 hours. So we're going to multiply that by 7. And we wind up with 476 miles. So if I'm traveling at a rate of 68 miles per hour for 7 hours, I would wind up going 476 miles. And there's our answer slide. All right, so we are completed for today. I hope this was helpful to you. And if you'll show up for the next video. Thank you so much for watching, and I'll see you in the next one.